Hello, this is John Carlisle. I'm just going to take you through how to use this survival calculator. This particular version is April 2019. That's when I'm speaking to you. Today's the 25th of April. The versions do generally change once a year, but sometimes they update them more than once. Usually in October, after the Office for National Statistics releases the most recent survival tables for the UK population. I'll also do another video that explains some of the calculations behind this survival calculator. The particular version I'm showing you now is called a clothed version because I've hidden a lot of the nuts and bolts. For instance, there's a whole load of pages that I've hidden. There's another version called the naked version that shows you all the pages and all the equations, and you can change them as you wish. Okay, so how do you use it? Well, there's 3 sheets that you'll be using. This particular sheet is called Enter Data here for obvious reasons. And you enter your data where you can see a yellow font with a grey background. Okay. Now the first question is whether this is abdominal aortic aneurysm surgery or not. I've currently put no, and I'll leave it as no. The next thing is year, self-explanatory. Then sex, male or female, age in years, weight in kilograms, height in centimeters. Has the person had a heart attack or not? Have they had angina? Have they had a stroke? Have they had a TIA, transient ischemic attack? Have they got heart failure? Have they got peripheral arterial disease? And then 3 blood results: hemoglobin in grams per litre, albumin grams per litre, and creatinine concentration in micromoles per litre. Then either a measured or estimated peak oxygen consumption, a measured or estimated ventilator equivalent for carbon dioxide at the anaerobic threshold, or alternatively the slope, a fudge factor, which I won't talk about in this video, and then a number that indicates how much does the person's mortality hazard increase after the operation. Then their background risk of dying per month in percentage, their post-operative risk of dying the first month after surgery, and the difference between the two. You'll see that there may be a apparent discrepancy due to rounding, so 0.08 minus 0.02 is 0.06, and yet the difference is rounded to 0.07. And at the bottom, the equivalent age. So I've basically put myself in. I'm 52. Because my fitness is a little bit better than predicted, my risk of dying is sort of equivalent to the average 44-year-old man, so somebody 8 years younger. The estimated ramp, this is to help you decide what ramp to put the patient on. This would be too low for me, or rather I could pedal against it and I'll just keep on going for, I don't know, about 17 minutes or so. So, well, let's see how changes in these values can change what you're seeing over here, which is the survival curve. I have left it as a 15-year or 16-year projection into the future. So the horizontal axis is years from now, and the vertical axis is probability of still being alive. So at some point in the future, we will all have a 0 chance of being around. So for all of us, survival is some type of slope from top left down towards bottom right. So let's put in, say, sort of an average patient, so say 78 years old. We'll leave it as a man for the time being. Let's make them a little bit fat, so 94 kilograms and 177 centimeters. And you'll see over here the slope's doing something whilst we do this. Let's say they have had a heart attack sometime in the past. And then we can go down to some blood results. Let's say they're a little bit anemic. Well, first of all, let's go down to their predictive value, because the hemoglobin is predicted to be a bit lower for people as they get older. And let's say they're a bit anemic, 724. Let's put in their predicted albumin. Let's say their albumin's normal. And let's say they've got some renal dysfunction, say 118 micromoles per litre. The predicted oxygen consumption, so let's say you don't bother or can't or whatever, you don't do a cardiopulmonary exercise test. On average, the observed physical fitness is around 80% of that person's predicted. So let's just put in 1350. Ventilator equivalent, so that gradually increases as gas exchange deteriorates with age. And let's say they're a smoker and a bit of emphysema, so let's say this is 38. Okay. So what have we got? We have got background survival indicated by a faint dashed grey line. We have got a post-op survival, so we've just got two survival curves printed out. And for this particular operation, I have said that I think their risk of dying the month after surgery will go up 5-fold, from a background risk of about 9 in 1,000 or 0.9% up to a risk in the month after surgery of about 44 in 1,000 or 4.4%. And there's the difference. This multiplier of 5 would be consistent for something like colorectal resection or nephrectomy, something like that. If they're having a hip or knee replacement, usually I'd use multiplier of 2. TRP hernias, you can use, you don't have to use integers, you can use a smaller value. And you'll see down here, for a 78-year-old man, 94 kilograms, 177 centimeters, this machine is trying to help you plan a ramp on the cardiopulmonary exercise test of 9 watts. So you'd expect that the oxygen consumption would go up by 10 mils per watt. We are planning for a 10-minute ramped period, so 9 watts times 10 minutes is 90 watts at the end of the test. And so the oxygen consumption will have gone up after 10 minutes by 90 times 10, so 900 mils. And one would expect their background oxygen consumption to maybe around about 300 mils. So at the end of freewheel pedaling, it would have doubled from 300 to 600, plus 900 we'd expect around about 1500, so it's not too far off 1350. Okay, so what happens if you're auditing data from, say, 10 years ago, so from 2009? Put that in, and you'll see that survival was a little bit worse in men 10 years ago. You go back another 10 years, you're auditing data from 1999. Again, somewhat worse. And then you put in 10 years before that, 1989. Okay, there we go. So is there much more to it? Not a lot. That's what you put in most of the time. If you put in yes to AAA surgery, then you no longer have to put in a value in here. What you do need to put in is the diameter, maximum diameter of the aneurysm. Here's 72 millimeters. And you'll see that there are 2 additional lines. Black is survival without AAA repair. So if we make the aneurysm, say, 45 millimeters, then survival's improved because the aneurysm is not killing them, but lots of other things are killing them, pneumonias and so on. The 2 red lines, one is survival after open repair in solid red, and one is after endovascular repair in dashed. If we have somebody younger, so the average age of AAA of repair of intact aneurysms is 74 in the United Kingdom. Let's say they're not quite so fat, so let's say they're 84. Let's say they haven't had a heart attack in the past. Let's say they're not anemic. Their albumin is normal. Their creatinine concentration is normal. And let's say their fitness is good. Let's say they're not a smoker without emphysema, so gas exchange fairly good. And let's say the aneurysm is 50. So you'll see here that the median life expectancy, the point in the future that half men just like this one would have died without aneurysm repairs, about 6 months, so 6 years 9 months. After endovascular repair is about 9 years, and after open repair is about 9 years 8 months, something like that. So that's how you use the calculator. Over here in red are default hazard ratios. So I would suggest you don't change these. Simply put, they tell you how much hazard ratio for death increases if you have had a heart attack, so 1.5 times, stroke 1.5 times, and heart failure 1.5 times, and peripheral arterial disease 1.5 times. If they're anemic, then risk goes up relatively by 11% or 0.11 for each gram per litre you're anemic. Risk goes up by about 7%, 0.07 for each gram of albumin each mole of albumin you're below, each gram, each gram you're below predicted, and similarly for creatinine concentration, although this is for the EGFR, the calculated EGFR. So this is the front sheet. You've got a survival curve that changes as you go along. Two other tabs available. This one gives you basically those curves in numerical form, and you can copy and paste these if you are auditing data you want to generate and record the survival curves. And the third one is a spreadsheet that we use in Torbay, and we print these off and keep them in the notes. It summarizes some of the CPAP results and some of the characteristics of the patient, so age, height, weight, and so on. Body mass index is calculated on this sheet as well. We also have got 3 standard EGFRs calculated from the creatinine concentration, a hybrid EGFR that I developed, and the expected EGFR for a man at this age. Let's give this man renal impairment and go back to the sheet. You'll see that the expected EGFR is the same, but the calculated EGFRs have fallen. The variables that one would need to put into this sheet are in yellow, and in fact these two here should be in yellow. I'll have to change that. Put in the spirometry values that you measure before the test is done. You put in whatever the peak power was reached, anaerobic threshold, whatever it was you estimated, peak heart rate, oxygen uptake efficiency slope, if that's something that you record, and the ventilator equivalents for oxygen. The CO2 ones comes from the front sheet. And then also we generally put in some comments in this column here. Okay.